So yeah, we're going to go from our nice lunch and we're going to talk about poop a little bit and how we control where it goes after it leaves the animal and how we reduce risk. I'm going to cover just real briefly. This is going to be a whirlwind tour of a huge research program that's highly collaborative, multi-state, multi-year. But give you just a few highlights, starting with some of our prevalence studies. The how much, what animals carry these pathogens, how much, what types of farms, what are the risk factors. Then I'm going to say a little bit about some work we've been doing with FDA on manure and soil amendments and pathogens, and then give you an example. There was kind of a neat study that was done in tree nuts and in proximity to a concentrated animal feeding operation, in this case poultry, but it brings up some examples of mitigation strategies, which is really where we want to get to in all of this, is a prevention model. So just to remind you, a lot of my work has looked at wildlife and livestock interactions in the produce, especially leafy green growing environment. And but we don't live in that vacuum. There's many other sources to look at too, with water, workers, and so on. This slide I threw in just to remind me to say that this is really complex. It's not all the E. coli 0157 comes from cattle, and Gabby alluded to that. It's more nuanced, and if you go around through the literature and you test enough fecal material, you can find this pathogen in practically everything from a fly and a protozoa all the way to a human. And so unraveling, which of these animals and critters are the most important is what we focus on in our research. So I'm going to go back to where it all started. In 2006, with the E. coli 0157 outbreak in spinach that Mike talked about before lunch, that wasn't only the beginning of the rapid response teams in Calvert, but it was also some of the first data out of California on E. coli 0157 in animals. There hadn't been a lot of research, and there was almost like a mini research project that happened during that investigation, and we all identified the cattle and the feral swine and surface water and sediment as having the bacteria, including the outbreak strain. And bringing up what was mentioned, this was actually a grass-fed beef ranch with land that was leased for leafy green production and transitional organic farming. And as a result of this, there was quite a storm that didn't so much involve the beef industry. There was a little bit of that, and there were definitely some meetings that took place with the cow-calf operations and discussing the results of this investigation and where we would go with research and rolling cow-calf operations into studies that Rob Atwill led, and I moved from the state over to the university to do some of this research. But what really got a lot of attention was the effect of finding the pathogen in feral and wild animals, and this created some controversies and some conflicts even with the conservation community and the food safety community. So over a decade ago, these same kind of meetings were taking place, and they were tense, and it was actually the conservation community at the table, and Joseph was involved in some of those, facilitating some of those meetings, and in the end, he came out with this concept of co-management, where it's an approach to minimize microbiological hazards associated with food production while simultaneously conserving soil, water, air, wildlife, and other natural resources. The idea being that we don't compromise conservation and wildlife on our farmscapes, but we also don't threaten public health. We look for a balance, and I'm just going to throw out there in our discussions for this afternoon, is there a place to add in animal agriculture into this concept of co-management and having a preservation and coexistence of animal production and produce production, which has been going on for a long time, but now we are here at the table realizing that there are some issues. that are impacting both industries. In the research, some of the early research we did, what did happen after 2006 was we had the LGMA, but we also caught the interest of the USDA funding sources and Center for Produce Safety and received funding to do quite a bit of research in the Salinas Valley and the surrounding Central Coast areas where we have rangeland cow-calf, produce, major specialty crops including leafy greens, and then important riparian and wildlife corridors. So we began a study, and we thank all of the ranchers and growers that were willing to enroll and take a risk. These were some of the first studies we did in the context of produce food safety, and of course there's some nervousness of what was going to happen, and the first word on this slide is what I wanted to emphasize. When we do our research and we work with commercial producers, we have confidentiality agreements, and this work started in 2008, and it's now 2019, and we've continued to work in the Southwest desert. We recently did this manure pathogen survey on private locations, and in my whole career so far doing this, at locations all across the United States as well as here in the West with collaborators. Never had a breach of confidentiality, never had somebody got turned into the FDA or had somebody who got into our database and could identify where the farms. We have a very good system to protect that confidentiality, but still be able to learn on commercial farms. And I just want to emphasize that we are greatly indebted to the producers who cooperate and help us learn about these pathogens. I'm not going to show all the data. I love all the data, but one of the main take-home messages from some of these studies with cattle and wildlife is this interesting seasonality that Gabby alluded to. And we do see this summer-fall peak in E. coli 0157. And this has been seen in the past, well before 2006. It was studied in Nebraska and Kansas on large feedlots and first noticed. And interestingly enough, on the Central Coast and now going down into the desert in Yuma and Imperial Valley, we're still seeing that same interesting trend, mostly on the feedlots, but in the cow-calf operations, we see lower levels, but then we'll all of a sudden see a spike, like a hot spot, and we're still trying to figure out what causes that phenomenon. So the other project I was going to mention is this one where we've been across multiple states, been commissioned by FDA to gather data to inform policy related to soil amendments, and so we're collecting quantitative data of manure-borne pathogens, and we've been doing this work on different size farms. We've been on big dairies, micro dairies, composting operations, looking at feedstocks, and small farms all the way up into the Cascade Shasta area. And we have pretty consistently found that STEC is present in this stacked manure, and if it doesn't go through composting using validated time temp methods, you can find it, and it can persist even in hot environments, and it's present on all sizes of farms when we find it. And this last study that I was going to mention was done with Linda Harris in food science, and we hooked up. She mostly looks at tree nut orchards and processing of tree nuts, and I mostly looked at livestock operations, and so we actually had a study with Center for Produce Safety as well as with FDA funding through Western Center, where we had a large poultry operation that was directly surrounded by almond orchards. And so we set up aerosol samplers and measured movement of dust going from the edge of the poultry operation into the tree canopies out to 650 feet. And we couldn't find any pathogens or even indicator E. coli in these air samplers. It was hit and miss, and the technology just wasn't there. So we ended up using what's called next generation sequencing or metagenomics, where we actually found a fingerprint of a profile of bacteria. So all kinds of different families of bacteria, and the dominant families actually were associated with poultry. And we showed that the first 1 to 3, 4 rows of trees may actually serve as a barrier. We saw a gradient of decreasing bacteria and decreasing physical dust going from that operation into the trees. And I think that has implications for using these shelter belts. I had to look that up and throw that in there because it was a new term I learned this morning. And boundary trees, hedgerows to reduce bio-aerosols. This is all already going on to control dust and may actually have food safety implications as well. So in summary, the fact is that many of these zoonotic foodborne pathogens, such as E. coli 0157, do live naturally in the gut of healthy animals, both wild and domestic. They're part of our environment. They're not going to go away. We're not going to eradicate them. So they can be a source of environmental contamination. But we are starting to see risk factors such as seasonality, sporadic hotspots, and areas where we know there's higher risk and where to focus attention. And I think where we need to go with research is, to look some more, as has been coming out in this meeting, at the setback distances, other mitigation strategies. How do these pathogens move around, and do this specific to geographic regions and practices for those regions.